All right, 18 homework. And number one. So it's a piecewise function because it's three different pieces. So let's handle them individually, right? So the first one, they're all constants. So these are going to be known as step functions. So they're going to be flat, horizontal lines, right? Horizontal line through 4. Right, here's the horizontal line through 4. But again, we don't want the entire line. We only want a piece of the line. What piece do we want? We want the part that is less than -2, right? X is less than -2. When X is less than -2, use Y equals 4. That's what this is saying. So at less than -2, right? This is the part that we want. Right? That's the part that we're concerned with. And it's going to be an open circle. Oh, it's going to be an open circle. It's an open circle because it's strictly less than, right? Strictly less than. Okay. Second one. Y equals 1 if X is between -2, including -2, and 3, not including 3. So Y equals 1. Y equals 1 is this line. Again, we want between -2 and 3. So between -2 and 3. So -2 is included, so close circle. And then 3 open circle because less than. All right, then finally, we want X greater than 3, use Y equals -3. So Y equals -3 is this line. This is Y equals -3. But we want X greater than 3. So at 3 and greater. So notice, right? Where one function drops off, the other one picks up. So there it is. All right, the domain, right, is all real numbers. There's no gaps, right? No matter what X you choose, even right in this area, right? Like even here, at X equals -2, Y is equal to 1, right? It's well defined. And then when Y is equal to 3, it's also, or when X is equal to 3, Y is -3, right? At X equals 3, Y is -3. So again, it's well defined everywhere. So all real numbers. The domain is all real numbers. Now, the range, however, there's only 3 values, right? There's only 3 values for Y. It is -3, 1, and 4. So we have to use set notation, right? When we're talking about individual numbers. So -3, 1, and 4. Now, you may be wondering, like, bro, aren't we supposed to put something that looks like this in there? Yes, only when you have a continuous range, right? When, like, this right here is what covers the range from dot to dot, right? Like, if somehow this was continuous, right, then yes, we would put this because that hits every point in between certain points. But we don't have that situation, right? There's only 3, right? Either this function is going to be -3, or it's going to be 1, or it's going to be 4. There's literally no other outcome. So those are the 3 outputs. And that's how you do it. You set notation when it's individual numbers. So -3, 1, and 4. All right. Let's look at the next one. Hey, it costs $30 a day or $90 a week to rent a steamer. If the time in days is not a whole number, it is rounded up to the next greatest day. So customers are given the weekly rate if it is cheaper than using the daily rate. Okay, so what's happening is on the x-axis, this is our days. On the y-axis, this is our money, right? The cost. Okay, so let's see, so we can call these 1, 2, 3, 4, 5, 6, 7. We can go 30, 10, 40, 50, 60, 90. Okay, so what's happening is that when you rent something, this particular steamer, it's $30 a day, no matter what. So even if you have it for 0.1 of a day, you're still paying $30, right? No matter what time before the first 24 hours, right? One day is 24 hours. In that first 24 hours time span, you're paying $30, right? At 1 day, I'm paying $30. At half a day, I'm paying $30. At 1 hour into that day, I'm paying $30. If I only had it for a minute, I'm still paying $30, right? Because that's what it means by if the time in days is not a whole number. Well, 0.1 is not a whole number. So you round it up to the next greatest day, which would be 1 day. Okay. At 1.1, 1.1 would get rounded up to 2. Right? 1.3 would get rounded up to 2. 1.5 day. Right up before the second day. And then turn it in right at 2 days. Right? All this time here. And then at one day, at x equals 1, we need to put a circle. Right? The graph has to start somewhere. Well, if they tell us at 1 day, use $30. Okay. If you keep it 1 minute past 1 day, it goes up to the next day automatically, all the way up for 2 days. And the same thing is going to happen for the third day, right? On the third day, the very next minute after day 2, it's $90. Another $30 gets added up to 3 days. Anything past that, right? Say if I wanted to go to 4 days, well, that would be $120. Well, the weekly rate is cheaper, so it would just be 90 days. So really, we don't need this particular dot because it is continuous. There is a dot there, but the dot makes it look kind of confusing. So this would be the function that represents renting a steamer for $30 a day and $90 a week. Okay. Other questions? Write an equation. Okay, so this is saying f of x. So we need to write an equation. We're going to definitely have 3. 30, 60, 90. We use 30 if x is between 0 and 1 or equal to 1. We use 60 if x is between 1 and 2. Exclusively 2. And then if x is between 2 and 7, we use 90. Now notice, right, on the left-hand side are all the less thans. That's why on the left-hand side of the line, they're all open circles. And then on the right, or equals, closed circles, right? So hopefully you're putting those together or making that connection. Graph the step function. We did that. Okay. Let's see. Use the definition of the absolute value. All right, so to rewrite f of x equals absolute value of x over x as a piecewise function. Okay, so what's going to happen, right? Anytime you have a fraction, right? Anytime you have a fraction, division by 0 is always going to be undefined. So we definitely have a vertical asymptote at x equals 0. But the graph won't cross this line. The graph will not cross this line. All right, that's the first part, is that understanding that there's a vertical asymptote at x equals 0. Because you can have division by 0, right? Because if x is 0, you'd have 0 over 0. And that's not a thing. We don't know how to deal with that yet. All we know is that when we have a fraction with 0 on the bottom, undefined, that's what we say, right? Because there's no definition for division by 0. That's why it's undefined. All right. Now, if we let x equal 1, right, do a little side note, at x equals 1, we're going to get the absolute value of 1 over 1. Absolute value of 1 is 1, positive 1. 1 over 1 is still 1. So at x equals 1, y is 1. What happens at 2? At x equals 2, we're getting 2 over 2, absolute value. Right? Any positive number up top, the absolute value will still be positive. So no matter what x you choose, this is going to be 3 over 3, 4 over 4, 5 over 5. All this is going to equal 1. So what's going to happen is that we're going to have an open circle at 1 because the graph has to start somewhere. And it's going to go right on forever, no matter what graph we choose or number we choose. It's going to go right. And then if we choose a negative number, right, say x equals -1, well, then we'd have -1 over 1, or the absolute value of -1 over 1. Well, the absolute value is just positive 1 over -1, right? Because x is equal to -1. So we have the absolute value of -1, positive 1, over -1, because that's what x is. And we see that it would just be -1. Then if we say -2, we'd have the absolute value of -2. Well, that's just positive 2 over -2. So again, a positive over a negative is negative. So all these values would be just 1. And still an open circle at x equals 0. So this is our function, right? Now let's see if we can write a formula for this. So f of x is equal to, curly bracket. So there's two pieces. So I'm going to need 2 statements. So we're going to use 1 if x is greater than 0, strictly greater than. and use -1, right? Y equals -1 if x is less than 0. That one's tricky. All right, number 4. This one probably looks slightly different than anything you've seen before. So a step function called the integer part, right? Mathematicians are very subtle when it comes to naming functions or naming things in general. The integer part function. So we're going to be using only the integer part of these numbers. So what's happening is that if we let x equal a number, so say 0, right? At x equals 0, I want the integer part of 0. Well, y would be 0. Here, look, let's do it like this. We can call it y or we can call it f of x, right? F of x and y are the same at this level in the game. We typically say just f of x. We know that's y. Okay, so at 0, y is 0, because that's the integer part. So let's go a direction. Let's go to the right positively. So 0.1. Normally I would have wrote 0.1, but I need you to understand that the integer part of 0.1 is just 0, right? Like just the whole number part. So no matter what value you write for the decimal, right? 0.1, 0.2, 0.3, 0.5, 0.6, all this is going to be 0, right? Because that's all the integer part. So basically, don't pay attention to the decimal no matter what it is. We only look at the integer part. So it's going to be 0 up until what? Up until 1.0, right? Because at 1.0, the integer part changes to 1. So at 1, the y value is 1. So going back to this first part, there needs to be an open circle here because that's where this 0 value ends, right? And then that's where and then 1 is where the new one begins, because at 1.1, again, same story. We just want the integer part. So the integer part up until 2, right? Because at 1.9 is still 1. That's the integer part. And then 2.0, that's just 2. 2.1 is still 2, all the way to 2.9. Once you get to 3, we go to the next one. And then we get this pattern, right? This is what's happening. Right? Now we can inductively realize that, okay, this pattern will probably continue. In fact, it will. So, oops. That's open circle. All right. And then it goes to the left. So at, say, like -0.1, well, that's just 0. All the way up until -1. Because at -1, y is -1. The integer part, right? It's going to keep going. Or the pattern is going to continue. Right, it's going to continue on in both directions. So there it is. This is the integer part. Okay. Lastly, number 5. Consider the absolute value function. Okay? F of x is equal to absolute value of x plus 2 minus 1. So right away, like, I'm already identifying the transformations that's happening. So the inside part lies, that's what we teach. and this is going to shift left 2 units. The outside part, this is my vertical, and this is going to go down. It's going down 1 unit. That's a 1. 1 unit. Okay, so parent function, right? Just remember, or I'll do it quickly just so you can see it. Parent function is going to look like this. That's what it look like. So I'm going to take that and I'm going to shift it left 2 and down 1. So left 2, down 1. And it's going to open upward. And there's nothing being multiplied in front of anything. So it's just at the 45-degree angle, right? Up 1 over 1, up 1 over 1. And both directions. There it is. Domain for absolute value is always all row numbers, as long as there's no gaps, and there is no gaps. And so that's the domain, all row numbers, or you could say negative infinity to infinity. And then the range is going to be from the vertex, the y component of the vertex, up. So -1 to infinity. So for absolute value, it's always all row numbers, with the exception of this absolute value function, where there was definitely a hole here. This one looked different, right? It had absolute value, but the only time, so the domain here wouldn't be all row numbers. It'd be 2 pieces. This would be negative infinity up to 0, union 0 up to infinity. That would be the domain here. And the range would be -1, 1 inside of curly brackets, right? Because there's only 2 outcomes. So this is the domain, and this is for range. Oh, you can't see it. Domain and range. So that's what it would look like for absolute value to have a break. For here, traditional absolute value, using the parent function of just a transformation, this is what it would be. All right, what is the x-intercepts and the y-intercepts of the function? So the x-intercepts are when x is equal to -3, -1. So x-ints, right, intercepts are when x is equal to -3, -1. The y-intercept is at, obviously, x equals 0, but y equals 1. Right, 0, 1. 0, 1. All right, hopefully this helps someone. Have a good day. Catch you in the next video. Peace.